afternoon, everyone. Welcome to all the participants to today's webinar. It's hosted by IEEE Computer Society, Bangalore chapter. Myself, Vishwas, and Secretary Anand will take you through this 1 hour of webinar session. So today's webinar focuses on assessment of X in Y equal to F of X. Basically, the systematic analysis of readiness of data before you build machine learning models, because now with a lot of proliferation of AI and ML models for or in every walk of life, I think more than the models, the data that is fed to those models, the importance of analytics of that data is becoming really prominent. And we have Hima Patel from IBM to talk more about this. Hima is actually a research manager at IBM Research Labs, and she leads a team of researchers in the fields of NLP and machine learning. She has about 13 plus years of experience in companies like Visa, Shell Research, and GE. She is also an executive committee member of IEEE Computer Society, Bangalore section. She holds a bachelor's in computer science from GCET and I am Tech in Information and Communications Technology from DAIICT. So we've been lucky enough to host several prominent speakers. So this is the 5th in the Celebrating Computing webinar series this year. And I welcome Hima Patel. Thank you, Hima, for agreeing to be part of this webinar. IEEE Computer Society Celebrating Computing webinar series. We usually have the face-to-face celebrating computing tech talks, but this year we've been forced to do webinars and we'll continue doing that until the situation improves. And I welcome all the participants to follow us on these social media channels, and we'll be happy to answer any of the queries or questions you may have regarding Computer Society or IEEE or even these webinars. So without much ado, I hand over the virtual platform to Hima. So over to Hima again, and we welcome you again webinar. And I'm very hopeful that we'll have a lot of stuff to take home from this webinar. Thank you.
Thank you, Vishwas. Thank you, Anand. It's my pleasure to, talk about, y is equal to fx. So let me share my screen and we'll get.
Hima, before we
Yeah.
begin,
Yeah.
all participants kindly mute yourselves and turn off your video. Also, if you have questions, kindly post them in the chat window. The speaker will be answering them towards the end of the session in the Q&A session. Kindly mute yourself and disable your videos. Thank you.
All right. Thanks, Anand. Okay, and very good afternoon to all of you. Right. So I'm going to start this talk with a story, right? And the main character in my story is a data scientist. So let's call her Preeti, right? And the story starts like this: that one day Preeti, goes to work, and she receives an email, from a customer saying that they have for their current process they are gathering lots and lots of data, and they would like the help of Preeti and her team to build a machine learning model for them, right? And this is a very high visibility project, and so Preeti is super excited that yes, this is great, right? This is a project which has really loads and loads of data, and I'm really excited. Like I just can't, I just get started as soon as possible. Okay, so right, and Preeti gets on the data. She starts doing the data exploration, trying to understand the data, right? And then this process goes on, for weeks after weeks after weeks, and and after about 3 months, right? Preeti is now in a little bit of a different stage. She's tried uh, several standard models. They don't seem to work. She keeps on finding, every time she builds a model, she finds that she discovers a new nugget of challenge in the data. And right so and at this point of time, Preeti is thinking that wouldn't it have been very nice when, if there was a magic box which could tell me when I got the data, what are the challenges in this data? Can I really use this data for a machine learning model, right? To build a machine learning model? Because then I could have gone to my customers right at day one and told them that, hey, this is great. There is petabytes of data, which is fantastic, but really this data doesn't have the characteristics which are needed to build a machine learning model, or this data has just way too many challenges. So maybe she could have given a heads up to her customers and said that it's just going to take, this is going to be maybe a long drawn out project, right? Or she could have done her um, or more importantly, if she really knew what the challenges were in the data, she would not have to, tirelessly, go and, build a model, realize it doesn't work, do the debugging, figure out that, there is a new challenge in the data which she had not seen earlier, take it, correct the data, now go ahead, build a new model, and basically, go through the whole cycle, right? So and the whole goal of today's webinar is to see that can a magic box like that be provided to Preeti, so that she could take her data, pass it through the box, and it could tell her that, hey, this data uh, is challenging with respect to building a machine learning model in this aspects, and it is great with respect to aspects 1, 2, and 3, right? So that's what we are going to talk about for the rest 30-40 minutes. Okay. So let's get to the title of the talks, right? Y is equal to fx. This is in the machine learning lingo, right? This is a standard term where the goal is to say that, you want to learn a target function f that is best going to map your input variable x to some output variable y, right? So let's take an example and we'll distill this further, right? So let's take an example that, we want to build a classification model that can classify between, let us say, cars versus bicycles. Okay, so what would the data for something like that look like, right? Let's take typically, if we had to think about cars versus bicycle, right, one would say, okay, cars are generally, their weight is more than bicycles, so that might be a good feature. As well as the cost is quite different between cars and bicycles, and there could be several other parameters of how one could think about this problem. So let's pick up, let's say, your cost and weight, and let's say we have data in this form, right? Where for every row that we have, we have a cost value and a weight value for either a car or a bicycle, right? So this is what we call as input features, right? And now to make this data complete, right, we'll add one more column and say, okay, if the cost is high, weight is high, it's a car, right? If the cost is low, when weight is similar, it's a bicycle, right? And this is what we'll call as the output label, right? So in this example, your output label is basically the y, which is what you want to predict given some new data which has cost and weight, and your cost and weight is basically the x. Okay, and the whole goal is we are going to talk about assessment of x in this y is equal to fx kind of a scenario, right? So there will be a question here, and I will stop here for a minute and see, let's think, right? Why is this assessment of x important? Right? So let me ask this question. what does this number signify, right? When you look at this number, what comes to your mind? Any thoughts, suggestions that someone unmute themselves or maybe write in the chat window and we could look at it? Any thoughts? What could this 80% be? Anything? Is it like somebody's marks or accuracy? Okay, so accuracy is one thing. No, it's not accuracy. What else? What else could 80% be? Majority, no, not really. So 80% here, basically, the amount of time a data scientist spends in a data science project on doing data preparation, right? And this has been studied that, and there have been several such surveys which have come back to this conclusion that data preparation accounts for about 80% of the work of the data scientists, right? And it is, it's the most time consuming activity, and it's really not fun for data scientists, right? Now the question is that, why does it take, such a long time to do high data preparation, right? And this is a loaded question which has several answers, right? But one particular answer to that is that, if the quality of your data is bad, right, it is going to lead to a higher data preparation time. So let me explain that a little bit further by what I mean by that, right? So what we see on the left is a typical, ML life cycle, right? Nice and clean, right? It's a theoretical life cycle, right? But actually, in reality, the life cycle is something like this, right? Because a data scientist starts with exploration, right? Goes around, does some cleaning, builds a feature, builds a model, and realizes that the accuracy is not great, goes back, does more data analysis, more cleaning, right? Maybe more gathering, right? Build newer features, and so it's really an iterative debugging cycle, which is both cumbersome and time consuming, right? And remember our friend Preeti, right, from our story, who spent weeks and weeks looking at the data, and only after many months was able to conclude that the data had a lot of challenges, right? So the whole goal of this exercise is then to say that at this stage, right, when we get the data, right, can we find out about how good is the data, or what is the quality of this data for an ML task? And if we could, give this to a data scientist right at the start of the process and say, hey, this data is great, and it's not great in particular dimensions, the data scientist really can make informed decisions. So if I knew at this stage that, for instance, my data has this problems, I'm going to, clean it in particular fashion, right? Because I know now what the problems are, I'm going to clean for those problems, right? So that's the whole goal of why we would want to, quality assessment before building a machine learning model, right? And just to summarize everything we've been saying so far, right? Typically, right, a data scientist, right, anyone in the research community, we've spent lot of time, building, improving our ML models, building more smarter models, models which are computationally more efficient, and so on, right? But really, the quality of a model is going to be affected by the quality of the input data, and this is a big gap within the whole data science life cycle that we are trying to address by our work at IBM Research. Okay, so the solution that we propose, that given our data, right, we want to find out the data quality issues present in the data and point to regions of data with low quality. So a data scientist, right, could really do informed data pre-processing or better feature extraction, or or build a model that can actually take care of some of the challenges in the data, right? And also important is that there are a lot of other personas. So in an enterprise data science project, data scientist is in the charge of building the data science lifecycle, but will typically, has to, uh, collaborate with subject matter experts, people who own the data, and so on, right? So, for instance, let's say if the data scientist finds some issues in the data, right, and she's not sure whether what is the right cleaning mechanism, so she might have to go back to the subject matter expert and say, hey, I find this challenges. Can you help me, right? And so we also have to think about solutions of how will we make the subject matter experts' life easier, because they usually don't have that much time to really look through loads of data, right? It typically almost never happens in real world in that way, right? So the whole goal, right, to summarize, is that there is a challenge in terms of quality. If the quality of data is bad, there is a challenge. It affects the whole data science pipeline. And what we are trying to address here is to say, can we build systematic solutions, and algorithms which can analyze the data at step zero, and and basically give out like a JSON which says that here are the different quality metrics, and here is how your data fares across each of the quality metrics. And if your data fares bad across a particular quality metric, then we want to point to regions of the data so that a data scientist can maybe just take that chunk of data and go to the subject matter expert and say, hey, I think this is a problematic data point. Can we sit together and try to understand, or can you explain to me, the process that is generating the data? Why would we expect data of this nature, etc. Okay, so that's the big picture, right? Now, moving forward, before we actually go forward and talk about the solutions and and some of the techniques that we have built, I will also show a demo later on. Right, I wanted to spend maybe few minutes to differentiate this from traditional data quality, right? So data quality within the whole database community, right, is a fairly well established area, right? And this is also something that is you could find a lot of data quality tools and techniques in a bunch of well established products, right? But the whole goal here, in the way I think, it's now looking at data quality from a different perspective, because all the other data quality measures that have been developed and they exist, they are um, they are all with respect to ensuring that your data lakes are consistent. There are no integrity violations, there are no uniqueness violations. Your database is fine, and they're all where the whole upstream task of it is to either do BI or reporting or other things out of it, right? So these quality measures do not address the the quality issues which will affect a machine learning model, right? And that's the kind of gap that is the that's where we are trying to build solutions to address that gap. Um, so moving Uh, so this is, the high level of the solution of, how do we think about data quality, right? So the base part of this is as follows, right? We want to look at, several dimensions and say that, I'm going to look at your data from, so many different dimensions, and for each of the dimension, I'm going to measure the quality of the data. And like I said earlier, give a data scientist a JSON which says that, here are these 15 quality metrics, and this is how your data fares across, some of these quality metrics. Broadly define these dimensions, and then we'll do a deep dive in one of the dimensions and take it forward from there. Okay. So the first dimension that we look at is labels, data labels, right? So remember, right, in our car and bicycle example, we had we had the cost and weight, which was basically the X, and then we had a column which said this is either a car or this is either a bicycle, which is basically the column Y, also in common lingo called as the label column, right? So data labels is a very important column with respect to a machine learning model, because machine learning model is going to say, of the training data that you have given me, right? One, I do need the labels to build any kind of supervised classification system. So absence of labels is one problem, or missing labels is one problem. The second problem is that what if the labels that you have provided to me are incorrect or noisy? So again, let's go back to our car and bicycle example. Let's say typically for the purposes of our discussion, let's assume that cars always have a higher weight and a higher cost than bicycles. Okay. So if you have certain rows in your data where if the cost is high and the weight is high, right, and it is labeled as a bicycle, right, this is what we call as noise in the label. Correct. And why will this affect, right? This affects a machine learning model because a machine learning model basically looks at the training data and really looks at it as the golden truth and tries to basically estimate this function so that given new points, it can basically tell you whether it's a car or bicycle. We have taught it, if the data that we use to teach a machine learning algorithm is incorrect or noisy, then the machine learning model is going to get confused and not, build a strong generalizable classifier. Right. So that is a dimension of data labels. We'll talk a bit more about it, right? Then there's a whole dimension of what we call as data richness, right? Which is basically asking the question that, is the data that we have, is this even rich enough to build a machine learning model, right? And what does that mean when I say rich enough, right? Does this data have, challenges of, like, let's say, uh, uh, challenges of where the classes are overlapping with each other, or the features are very, very weak, or right, or it has lots of outliers, or it has the data set is imbalanced and overlapping, or the general classifiability of the data is low, which means that the data doesn't have enough strong patterns by which you could build a classifier, right? So that's the whole dimension of basically looking at your X. So in our running example, it is the cost and weight columns, and try to find out, look at that from several dimensions and say that, what are the challenges in this data with respect to the patterns in this data. The next one is, let's say, this is an interesting one, right? And very important also in enterprise settings, where, we want to also look at, privacy and trust and, of things in that nature. So let me give you an example that, for instance, do we, we want to look and find out that, does this data have any PI sensitive information, right? If the data has PI sensitive information, maybe it has to go through a governance route in the whole enterprise, where the PI or the SPI data can be masked or removed as per the organization's policy before the data can be shared with data scientists to build their models, right? And PI SPI is one example of privacy. There could also be data which is sensitive data, which is data coming out from a process to which people need to have certain permissions before they can really access their data, right? So there are a bunch of problems in that angle, right? Moving further, right, is the point of general cleanliness of data, right? So does your data have a lot of outliers? Does your data have a lot of missing values, right? Does your data have mixed data types, right? So in a given column of the data, right? Do we have are all the values consistent or not, right? And let me give you an example of in an enterprise data set, right? In an enterprise data setting, what some of these issues are caused because of how we acquire the data, or these are caused because consider a scenario that to get the data to build a machine learning model, data is acquired from two different databases, right? Now let me take a simple example and say that let's say it's a gender column, and in one database the gender was being stored as male and female, whereas in another database the gender was being stored as M and F, right? And now that we have integrated these two different types of um, data, even though it's all the same gender data, your new column is going to have half of the values as male, other half as female, and then also some values which are M and some values which are F. Whereas the ideal scenario could have been that all the male values and the M values, they basically they're not the same thing, right? But to a machine learning algorithm, it's going to think of it as four different categories. And moving further, right, like effectiveness of the data, right? So uh, does this data really have, so can I in some form find the value of this data, right? Are there points in the data set which are more valuable for building a machine learning model, and are there other points which are not so valuable? And the points which are not so valuable, can I remove these points, right? So how much is my machine learning model going to get affected? So remember, our data scientist Preeti, when she got her data, it was really petabytes of data. In that petabytes of data, a large portion of the data doesn't help towards building the machine learning model. If she had a solution like this, she could filter out the data which is valuable towards building a machine learning model, and maybe it would save her time, and it would save her cycles to do her data science work, also easier in terms of lesser burden on compute facilities, right? So I'm going to, take a pause here and see if there are any questions at this point, because the next part of the talk, we are going to, focus on a specific algorithm, and, we'll do a deep dive into it, and I'll show you some results and a demo and so on. So if there are any questions, right, maybe we can, take a small break here. And then should I be looking at the chat for any questions?
We don't have any questions yet.
Okay, so then maybe let's continue. Let's continue to the next part of the talk. Okay. So what I thought will be interesting is that we let's pick up one of these dimensions and let's really go deep dive into it. And I wanted to show you, what it really means, right? So, but before we do, want to spend a little bit of time and talk about, because we've been talking about our friend Preeti, the data scientist, a lot. But I also wanted to give a flavor that who are all the personas in a real enterprise world. Your data scientist is obviously an important persona, right? But in an actual world, right? To take your models, to put your models in production, people who are part of this whole data science life cycle, right? So we have spoken about, the friend data steward, who basically is the owner of the data, right? And he governs, right? What are the changes we have made to the data, right? What are some privacy issues in the data that have to be taken care of, right? Then there's also our business user, who is looking at, who brings in the dimension of who brings in the dimension of what is the problem to be solved, right? And the data scientist typically needs to work with the business user to take the business problem, and from there work with the data steward and try to define in a given data set what would be the x and what would be the y. And then we have the subject matter expert who really understands this data, how the data is acquired. So let me give an example. For a given process which is generating data, having some values which are missing in the data could be an indication of something, right? So the data scientists, when they look at missing values, they really have two choices. That can I just impute some of these missing values in some standard form? But it's possible that if there's a missing value, let's consider an example that data is acquired from several sensors, and maybe missing values in more than in a few rows together might mean that there's maybe the sensor was faulty, right? So instead of blindly applying a missing value imputation, the data scientist usually consults a subject matter expert and says, okay, this is probably what it means, and this is what I'm going to do for this model. Okay. So with that, we'll move further, and we're going to do a deep dive on the dimension of labels and talk about the problem of label noise, right? So most of the large data sets that we have, they are, that are generated or annotated, have some noisy labels, right? And the goal here is that we want to answer the question, how can we identify these labels and correct them to make the model better. Okay. And we'll talk a little bit about where why the noise comes in the labels in the first place, right? But before that, let's understand what we mean when we say label noise, right? So I have some interesting examples here. Right, so this is from a data set which is called Google Quick Draw, right? And the given label for it is a mosquito, and this is definitely not a mosquito, so which is a clear case that there is a label noise here. Similarly, in the standard MNIST data set, right, the image clearly shows the picture 3, but the label is. Similarly, if you look at this line which says that I have had this for over a year and it works very well, I am very happy with the purchase. It clearly indicates a tone that a customer or whoever has written this review is quite happy with the purchase. But if you look at the label is basically a 1-star review. So clearly, I mean, these are all cases where these are incorrect labels given to these data points, right? And what is the effect of this incorrect labels, right? Like I was saying earlier, right? One, they can lead to a decrease in the classification performance because your machine learning model really relies on the training data to learn what kind of function it should be said to separate two classes, right? It also poses some kind of threat to tasks like feature selection, where feature selection techniques are dependent on the target variable, right? And let's say if data is collected in an online setting, then the new data may really contradict with the original label data, which is another issue, right? So this is the problem of noise in the labels, right? But then the interesting question is that where does this noise come from, right? Like why would this kind of a scenario happen, right? And it's and the answer to it is quite straightforward, right? So some sources of label errors are uh, labels basically come in the data in a variety of ways. Uh, Either by the use of automated systems for weak labeling, which is a typical scenario in enterprise data settings, or it is the case that insufficient information was provided to the people who are annotating the data, right? The other scenario is that there were 5 people annotating the same data set, and they have different levels of expertise. So looking at one point, annotator 1 will give it a label 1, but annotator 2 will give it a label 2. And in this case, right, if there are 5 annotators and they don't agree on the label, right, typically these systems will take like a majority or something, then there's a high chance that label noise can creep in to your data sets, right? And also sometimes the labeling task could just be subjective, so different users may actually think about it in different ways, right? So this whole field of how to acquire labels is a whole field by itself, right? And there are several platforms uh, which are like Figure 8 or Amazon Turk, wherein people would give their data sets, right, and human experts would help label the data, right? And because of this the reasons that I stated, label noise can creep into the data quite easily, right? And this is more pronounced in enterprise data sets because label acquisition is really quite hard and time consuming. So so this is a problem, right, which goes back to our dimension of labels and the quality of the data. And let's look at so here's an example of does it just affect machine learning systems? No, in this case, this particular paper has shown that if you do a lot of label corruption, right, deep learning systems, and these are the systems that they talk about, right? The test error and the time to both increases, right? This is a problem not just for machine learning systems. Well, deep learning systems are also machine learning systems, but what I meant is, not just into for a given possible set of classifiers, but this problem can occur, for any supervised classification model. Okay, so let's look at how we have been thinking about this problem, right? So the way to solve this problem is first we try to get an initialization and say let's find all potential noisy labels, and we may be wrong. We will call some of the initial labels which are actually correct as noisy, and that's fine. So that's just an initialization step. And then we basically have developed techniques to look at the data and look at the information from the current class and from the neighborhood classes to filter out noisy samples. So now we had an initialization, and now we have a smaller subset of samples where we have more confidence, or where we have pruned out the ones that are not noisy. The next step is to find out, overlapping regions in the data. So if there are genuine cases where the features are weak and the data overlaps between two classes, then then it may or may not be label noise. It could just be a case of bad features, right? So we want to prune noise samples that lie in regions, and then rank the noisy points by confidence. And whatever are the noisy points that we have found, right, they have to be shown to the data steward or the subject matter expert for the review, because in an enterprise data setting, your labels is the most important part, right? So you typically will need the data scientist will need permissions before they can actually change, right? Which brings an interesting problem, right? So the problem doesn't end here. It brings an interesting problem that the data steward or the subject matter expert may have limited time, right? So we also need to think about solutions of how we can make their job easier and not just focus on the data scientist persona, right? And this is how we have been tackling our label noise problem, right? And let me show you some results. Okay, so we went and we scraped like about 45 data sets from Kaggle, and we induced noise in this data sets, right? So we didn't know if there was noise already or not, but it could have been. but we basically induced some more noise, which becomes like a proxy ground truth for us. And we ran this through our algorithm, and you can see the precision recall rates, right? And right, so this is what we are getting right now. But this, I just wanted to again bring back you guys back to the big picture that we spoke about one particular algorithm within this dimension, right? So I do want to maybe take a minute more and give you like a feel of, will, what does this look when all of this is put together, right? So, so this is a demo, right? Where we are going to talk about, other metrics. See here in the demo, I'm going to pause this for a minute, is, a data scientist can come and upload their data. And once they upload the data, they come to an interface like this, which basically on the left-hand side, tells about the quality of the data with respect to 4 metrics that we have used here. What we have put on the right-hand side is we have basically taken a machine learning, classifiers from Scikit, and just plot it to give an understanding of as you change the quality of data, right? In some cases it will go and affect your machine learning classifier, in other cases it won't, right? And a user could also come and choose and say, what is a model indicator of choice? So accuracy could be a model indicator of choice, or somebody says that, in my given use case and my scenario, it's extremely important for me for the model to be fair, right? And it's fine, and I could do a little bit trade-off with the accuracy, and which could be perfectly all right, right? So that's what this layout talks about, right? And now we'll go through the demo and look at the different parts, right? So this is a metric, right, for this given data set. It is low, right? This is the label noise that we spoke about. Data fairness to find out, if there is any bias in the data, and classifiability to really say, does this data even have patterns to build a good machine learning model, right? And now what we can see, the buttons, right? So before that, we'll look at, the model indicators, which is accuracy and fairness. The lines that you currently see on the screen, right, for each of these are accuracy or the fairness numbers generated on raw data, right? So now let's transform the data. We found a homogeneity problem. It says that inhomogeneity was found in the gender column. Remember, we talked about this problem that we got data from 2 different sources. So some samples were male, others were M and F. But really, we need to, I think, make it into a consistent form, right? Where we have developed a technique and said that instead of having to do this one over again, really this is a tool which is built for data stewards or subject matter experts, because they are the ones who can really decide what is the expected value and what should reside in their database. Okay, in this case, the whole goal was to build a tool which doesn't require programming expertise, and asks the user and says that, hey, here are some representative samples, and can you, for 5-6 samples, tell me what is the expected output, right? And then we want to automatically learn a program that understands the transition from this input to output, and then that program can just be applied for all the data in the column, right? So we'll see that our user has applied given output for about 6 samples, and we see that we've applied the transformation. The quality has improved now. It also will tell you that how many rows were modified overall in your data set, and now everything is consistent. You can see that after transformation, the number of rows with male and female is 0. So, and we can see that this is what it does to your classifier. So a user can pick and choose and say, okay, I'm going to pick this metric or I'm not going to pick this metric, right? And let's see what happens from a fairness point of view, right? From a fairness point of view, because the gender column was important, right? You can see that the fairness values for each of these models have increased in most of the cases, right? So might be an important metric from a fairness point of view, correct? Let's look at label purity or label noise, right? And where we say, okay, let's go ahead and correct the labels, and you can see on the right hand side, how it affects the different classifiers, right? And again, it will tell you, how many rows were modified, and what was the initial actual label, what was the corrected label, and you can always click and get more details. Okay. Yeah, I will move forward. Okay. One is, to find bias in the data, right? Um, So we can see how the level purity affects the different classifiers here, and how does it affect fairness as a metric. Right. And we'll move forward back to accuracy and go to our next few metrics, right? And again, say if the data was biased, to debias the data. Similarly, if my classifiability score is low, right, I'm just going to go forward and just quickly show you that we basically do, I think, very similar things for the next two metrics, right? And say if the classifiability is low, the fairness was low, we fixed it. Now the quality score has improved. We can see this is how it affects, the different models when the indicator is fairness, right? And similarly for your final metric, right, where the classifiability is low, right, we can make suggestions of, what kind of normalization needs to be done, what kind of techniques need to be built, and so on, right? So I'll stop this here, right? Just want to summarize everything that we've been talking in the past 1 hour, where we've been trying to remember our friend Preeti, right? The whole goal is that we help aid the data scientist as much as possible by telling the data scientist about challenges in the data at the start of the process. So a data scientist can make informed choices about what kind of feature selection or data processing or models should be used process. And in this process, right, also think about other personas who are part of a data science life cycle in an enterprise setting, and build tools and algorithms to make of all the personas in an enterprise data life cycle easier. Right? So with that, I will stop here and see if there are any questions, suggestions, right? And also, I wanted to say that this is our ongoing research work. So if this interests you, you want to try out our toolkit, or you want to collaborate with us in any way. If you're a student, if you're interested to work with us, this is my mail ID, and feel free to drop me a note, and we can take it forward from there. Okay, with that, I'm going to stop sharing my screen so that I can look at the chat window and see if there are any questions.
Yeah. Participants, if you have any questions, kindly post them in the chat window.
Okay, Vishwas. So I think that's all from Vishwas and Anand. Thanks. That's all from my side. If there are no questions, we can wrap it up. And once again, I'd like to thank both of you to invite me. And I had a great time talking about the work that I and my team is doing at IBM Research in the space of data quality. Thank you, guys.
Yeah, Hima, while we wait for questions, I think we can wait for another 5 minutes.
Yeah,
So
sure.
I have some rapid fire questions for you.
Okay, all right. Did you not get my, package of chocolates in the morning at your house today? I'm just checking.
So yeah, the first question is,
Yeah.
how did you turn to computer science? Like, what was your inspiration to turn to computer science?
Frankly, I mean, as a kid who finished, the 12th standard, I think, I was thinking of what I could do, and it seemed like my choices were I either wanted to become a dentist or I wanted to become a computer science engineer, and then I just picked this one. That's about it.
Okay. So the next one is, what is your favorite memory about memory with computers? Like something that maybe it's just a program working, or you found something interesting in computer science, or you tried something out and it worked.
Right. Actually, I have a nice story. So, when I was a third year student, I had a professor in college who, he was taking a course. So, and we had to submit an assignment. So, I'd gone to his office to submit the assignment, and he was really a genius. So, his office really had all these books around and all. So I'd basically gone, I submitted the assignment, and I was just thinking that okay, I'll go home, do my things, right? And he picked up a book which was called Introduction to Neural Networks, and said, he just said, I think you should read this. I think you will like it, right? And I had no idea what it was, right? I also said, okay, yes, sir, thank you, and I just moved out of the room. I did take out time to read the book, and I got so fascinated by the whole thing that that's where I decided that I'm going to build my career working in the field of machine learning.
Yeah, awesome. Yeah. So before we move to the next question, participants, kindly post your questions in the chat window. Uh, we are moving towards the end of the session, so if you have no questions, we'll be wrapping up the session. So my next question is, what do you do apart from building the school or cool AI things or reading about stuff? What do you do in your free time apart
I
from
work,
reading about AI?
yeah, I work with you guys for the IEEE Computer Science Bangalore Society. But no, apart from that, I'm also very passionate, and I've been associated with this Anita B. Borg Institute, and I've been associated with the Grace Hopper Conference. So that's what I do. And I watch a lot of movies. I really like watching movies.
Okay, that's interesting. Uh, yeah, so uh, we have one question from Vishwas. He's
Um,
asking, is this work on data quality going to be part of IBM platforms in the near future?
yes, Vishwas. So it is planned to be part of IBM platforms, and it's also going to be available to our clients in about a month's time,
Okay,
as
that's great.
a separate offering before it goes into IBM platforms.
Yeah, that's great because we've been like solving some of the problems using IBM platforms in the past, Bluemix, Watson. So I was just wondering because the treatment of data and ensuring that the quality of data required to build those models is addressed at the very beginning. I think that is one of the important aspects that we need to look at. I think this talk was really good in bringing out that issue out, and I think if it is going to be becoming part of the overall IBM platforms, I think it would reach a greater audience.
Yeah. Sure. Thanks, Vishwas.
Yeah. So.
Uh, any other questions? Kindly post them in the chat window.
Yeah, I mean, even if somebody wants to just speak about it,
Yeah, you can
just
unmute yourself and
yeah, Mute yourself, and we still have about 10 minutes, so we can take a couple of questions for sure.
Okay. Anyone have any questions?
Just one more question, Hima, because we know that the majority of the data that gets generated, right, it's still at the edge. If I would say, for example, the industrial scenarios, factory floors and all that, it's not yet reaching the cloud, right? Because most of the platforms, be it IBM's or Google or even Microsoft and AWS, most of the models are trained in the cloud, and most of it is for the built for the data that reaches the cloud actually. But if you take real life examples, 80% or even more than that, I think it still gets generated at the edge or even beyond the edge, right? So how do you see this scenario? Because most of the models or even the data that you process, you assume that it's going to reach the cloud. So how do you or even IBM plan to address this issue?
Right. Yeah, so it's a very interesting question, Vishwas, right? And I mean, there's a two-part answer to it, right? One is to say that it's also a function of what do you want to do with the data at the edge, right? So do you want to, really collate all the data in in some fashion and use them together to, build a model, right? In that case, right, it's just a function of where do you place the data quality toolkit so that it could be used, right? But there's also a possible scenario where you say that the data which is it's just going to be a lot of compute infrastructure, and we can't really think about moving data and getting it all together, right? But I still want to use the data at the edges together, for the way I'm trying to build my models, right? Which is the whole field of federated learning. And so there is a concept that we're trying to build in our lab on federated data quality, but that's really, I think, in more native research stages right now.
Okay, so for example, if IBM is already, I mean, I know the Watson is great and a lot of mature models in the cloud, and if we can bring those models and containerize them, bring back those models to the edge, as near to the edge as possible, containerize them. So I think you already have some kind of framework in that regard.
Um, what you're basically saying that if we have models which we can containerize in some form, right, and let's say
Yeah,
Dockerize or whatever,
yeah,
right, and bring it onto the edge and see if it can process the data at the edge. Is that the question, Vishwas?
yeah, absolutely.
Right. Right. So that question actually goes a little bit beyond data quality because it's an infrastructure question of how to manage, right, the different how do you bring the container to the edge, how are you going to ensure the data moves around in the cloud, and what data can move, what cannot move, the governance issues there, and so on, right? So that's yeah, so I think it's a very, very valid point. I think it's a but it's just, I think, beyond, I think, something that, I am looking at within IBM. So,
Sure. I was just wondering, I mean, if IBM, not just from your research perspective, but I think IBM's plans or, because the industrial scenarios, generate a lot of data, and they're still wondering, how to process this huge amounts of data at the edge rather than bringing everything to the cloud.
no,
But they,
you're absolutely right, right? And I think this is a big initiative within IBM, where the whole cloud strategy is extremely important, right? So, yes, there are other people who are looking at problems like this.
yeah, sure, great, thank you. So I think there is one more
Yeah,
question.
we have two more questions. So we have one question from Rohit. So he's saying, I'm a student and I've been trying to read up a bit whenever I can, but I can't seem to find many interesting problems to work on. What would you suggest I do?
Okay, so if I interpret your question correctly, and Rohit, feel free to pitch in so that I've got your question right. Are you trying to read up and find interesting problems that can become part of your, coursework, or are you trying to look at interesting research areas? So it good will be good for me to understand, where you are coming from, so that
So Rohit, if you want, you can unmute yourself and ask the question yourself. Feel free to. Rohit, you're there?
Yeah, I think he has unmuted himself, but I think we can't hear him.
Yeah. Rohit, you're there? Okay. Yeah, you can put that in the chat. Don't worry.
I think you can type it until you read out the other question.
Yeah, you can clarify your question again. So we have another question from Harikrishnan. And he's asking, nice presentation. Yeah, he's saying nice presentation. If we have very limited training samples, in this case, how do we know which model should we be using?
Yeah. So I think that's a fairly common question, right? That if you have limited training samples, how do you go about with it? Um, uh, I don't think there's just by looking at the number of samples, right? You want to make that choice. You want to look at what really is your problem. Also, maybe ask the question that if I have few training samples, do I have enough data to build a model? Am I better off building maybe a rule-based system? Do I need a machine learning system in the first place, right? So, right, and if not, I mean, based on that, I think you'll get characteristics, right? And then is there also domain knowledge that I can pull in, because my training samples are limited. So in my model, can I put in specific loss functions, or different uh, regularizations, which will help in case of limited training data, so that you won't fall into the problem of overfitting data. But I think the answer to this lies, I think, beyond just looking at the number of samples, but also trying to understand what features you have, and is this data even well suited for a machine learning problem?
Yeah. So I didn't hear from Rohit yet. So we have another question from Bindu KR. She's saying, thank you for the wonderful session. And what is your opinion on using transfer learning for quick results?
Yeah, so transfer learning has shown a lot of lot of good results, right, in certain domains. So I mean, it's definitely a technique that one could use. Uh, I mean, said, right? I think it really depends on the problem that you have, whether transfer learning is meaningful in that scenario or not, right? Yeah, I mean, I would leave it at that, right? So transfer learning works very well in certain scenarios, and in certain scenarios it doesn't work so well. So it again depends upon what's the problem you're trying to solve.
Okay, we heard back from Rohit. He's saying, I have been solving standard neural network problems like classifiers and stock markets, but I'm not really satisfied. And what to find some real world research problems and try his hand in those. Yeah.
Okay, yeah, okay, Rohit. Yeah, thanks for the clarification of the question. If you're looking, into what are, interesting research problems, I would suggest that you look at some of top machine learning conferences like AAAI or ICML or KDD or NeuroIPS, right? And maybe just, I think, go through the flavor of uh, of uh, of what kind of problems are are typically interest in the academic community, and that I think will give you a flavor of what are the hot research problems, if you will, right, today. And then there's always, I think, based on what interests you, if there's a particular area that interests you, for instance, let's say label noise, and you can look at typically a good way would be to look at understand the field, what people have done so far, and try to find out what are some drawbacks that people have not addressed, and try to solve that problem, right? Because research is a continuously evolving thing. So right, there's always ample opportunity to find problems. I think this is what I would do if I wanted to look at uh, in the AI space, what are some interesting problems to pick up.
Thank you. Do we have any more questions? Yeah, while we wait, because you mentioned you watch movies in your free time.
Hmm.
What is your favorite movie which features AI or ML? I mean, something in a hi-fi tech sci-fi movie.
So there's it's not a movie, but there's a series which is called Person of Interest, which is based on the whole concept of anomaly detection. I thought that series was very well made.
Yeah, true. Even I am a big fan of that.
Yeah.
Yeah. So, which is your? I mean, for somebody who starts into, I mean, who is trying to step into the world of AI and ML, what would be your suggestion? Like, where should someone start when they want to like start afresh or want to change careers into AI ML?
Right. Yeah. Okay. Yeah. I think that's a very good question, right? Um, a couple of thoughts on that, right? My suggestion would be to, uh, find out. So AI ML is also broad, right? And within the industry for AI ML, there are lots different roles available, right? So there's a role of a data scientist, there's a role of data engineer, there's a role of a product manager, there's a role of a program manager who can so basically a bunch of plethora of roles within this field which have emerged in the last few years, right? So one is good to maybe understand that what is it that interests you, what is it that will really, I think, make you jump out of your bed in the morning. And once you get that kind of a clarity, I think my suggestion would be to um, learn the field systematically by taking courses at universities or courses with Coursera or other such lots of available courses, right? And understand it at the basics, and then I think go from there. That's what I would think.
Thank you. No, then that's all my rapid fires.
Thank you, Hima. Unless we have any more questions, uh, so I think that's it for this session. And it was a wonderful talk, because most of the times it's just a talk, and this was a bit special because of the demo as well, because people would be, getting a hands-on experience with such webinars. It's really encouraging for the participants and everyone. So we look forward to hosting more such webinars. And on behalf of IEEE Computer Society Bangalore chapter, I would like to thank Hima for this session and her time, and for all the participants as well for taking out your time out of a busy schedule, especially on a Friday afternoon. And do follow us on our social media channels. We'll be bringing you more events in the weeks to come. Thank you, everyone. And thank you, Anand, for being a great host again.
Thank you, Vishwas.
Thank you, Anand. Thank you, Vishwas.
Yeah.
Thanks a lot, Hima, for joining us. Thanks a lot, Vishwas, for joining us in this webinar. Thanks a lot for the participants for joining us. We are officially winding up the session.